Now here the function f of x is not given explicitly, but a relation in terms of x and y is given. Y times x minus y whole square equal to x. Then we need dx by x minus 3y. And if you look at the options here, all the options are in terms of x minus y. So we need to express this function as a function of x minus y. So let us consider for a suitable replacement u as x minus y. Then what happens to the given relation? The given relation can be expressed as y times u square is equal to x. So let us treat this as our second relation and the substitution value of u as x minus y as first relation. From both the equations 1 and 2, when we express x as a function of u and y as a function of u, then clearly x becomes u cube by u square minus 1 and the function of y becomes u by u square minus 1. Now, the given function's integral dx by x minus 3y, we are trying to express every term in terms of u. So, we expressed x in terms of u, y in terms of u, and left out is to find dx in terms of u. So, the required integral I, which is dx by x minus of 3y, is integral of derivative of x, that is u cube by u square minus 1 by x value when expressed in terms of u, that is u cube by u square minus 1 minus of 3 times y expressed in terms of, so it is u by u square minus 1. So if you look at the entire integral I is now converted in terms of u. So let us find the derivative of this numerator factor. It is in the form u by v. So differentiation of rational function, and in the denominator the LCM being u square minus 1, we'll place it in the numerator. So it is u square minus 1 by, how will be the denominator now? U times u square minus 3 into the derivative of this factor, that is u square minus 1 into derivative of u cube 3 times u square minus u cube into derivative of u square minus 1, that is 2u by u square minus 1 whole square du, right? Now we have separated the du factor also. Let's cancel the common factors which are available. Then u square minus 1 cancels in the denominator, and in the numerator u to the power of 4 terms when simplified would give us this integral as integral u du by u square minus 1. If you observe, the numerator's derivative with a missing 2 is there, so we will multiply and divide with 2. Then this is half times, how is the integral of 2u du by u square minus 1? Yes, it is ln of the denominator u square minus 1, but u is a function of x and y. So as we wanted the final answer in terms of x and y, let's replace u with x minus y. This is half times ln of u square replaced back with x minus y whole square minus 1 plus c. Let's see which option it is satisfying. Half times ln of x minus y whole square minus 1 plus c, which is presented option A. So even though we don't have a function of x and y clearly, but still we can convert both x and y as a combinations of u and get the integral and finally replace u in terms of x minus y, right?